All right, go ahead, Jennifer.
Thank you, Benita. Thank you all the people participating in this session. My apology. Originally, I want to be there in person so we can have more interaction in person and really coming out with a solution that we're trying to tackle. So this session really want to provide an opportunity to learn and share tools and capabilities by all the people in the community, whether you're from the state, government agencies, academia, private sectors, or local communities, that we can learn to accelerate data-driven decision-making process. So in a way, is we want to close the gaps from the data to decision-making with relationship with you all, that we can better understand the needs from the community, so we can work together to co-design or co-produce a solution or solutions. So we're very happy in today's session. We have invited three people from NASA or the communities, and two speakers from the panels, Benita and Makul, as we mentioned earlier. So we want to focusing on all the use cases that has been addressed for the climate issues they all encountering. So with that, we'll start having this specific use case from all the participants. At the end, we dedicated the time. Let's sort of discuss about what we have learned, we have seen, any problems that we can address together at the end. And that's all. And again, thank you for looking forward to fruitful discussion.
Thank you, Jennifer. So our next speaker is Mukul from NASA Applied Sciences. So screen froze. So good. Right.
Hey, thank you everyone for being here in this session. My background is in applied sciences, and I have recently joined the applied sciences team at Goddard. And my colleagues and coworkers are listed here, who we together are coming up with a strategy to have a workflow that is seamless in nature in terms of how data is pulled from the various sources and how it is presented to the end users. And by the end users here, I mean is external stakeholders and also internal NASA stakeholders who are familiar with the data but would like to see and experience a different form of data, if I may. So start advancing. So key areas that we at Applied Sciences are interested in is one, serving communities with key data products and co-producing them with partners to help with decisions, and also connecting NASA researchers with interagency activities and partnerships to facilitate practical, innovative uses of Earth observations for societal benefit. So these are pretty, detailed and heavy data-centric description, but at the same time, we want it to be careful for it to be practical and usable at the same time, and that's why these keywords. As Jennifer mentioned, we also have a couple of external stakeholders who are interested in NASA data and also use it and try to use it to public good and public services, including Bob, who would be talking about community side of things, and Joel, who would be talking also in terms of empowering decision makers with geospatial side of data wrangling. And we also have presentations, of course, from other NASA colleagues. So as we grapple with this problem of what is the best way and means of pulling data from one side of things and processing it and pushing it to another side in terms of users, capabilities, data stacks, and data stores across on-prem and cloud-based resources. So as you can see, there's a plethora of jumps and hoops that have to happen before the data is usable to the users. So on the top side, you'd see a linear flow, basically encapsulating the science, mission, directorate, and data groups, coming up with data holdings that they think should go downstream into users and for their benefits, passes through data stores and DAGs. And again, one component that is, of course, the cloud side of things, but that can also be seamlessly integrated. And then on our side, on applied sciences, what we have to have is a workflow which is more closely emulate the ETL process, extract, transform, and load, wherein, for those familiar on the IT computer database side of it, it has been done all the time. But now the only caveat here is that that data, once it's processed, need not only be in a certain file format, need not only be in certain infrastructure or in certain data stores, but be available on cloud easily as individual data files, or also be able to be rendered as APIs on an already processed workflow from external users. So all of that has to pass seamlessly, and then we have our internal groups, which we working groups that we discuss on the needs, data needs, and then the process gets shared across the chain, and then final data products come out to external data holders. So here's a little kind of decision flowchart, decision tree, if you want to call, wherein external stakeholders come, approach, or are directed towards us. We do a quick domain check to see if it's in scope and understand their data needs, format, delivery, their area of interest, and all of that is processed to understand if the data is readily available or not. And we're talking about data level 3, 4, and beyond products. So if it's available easily, then yes, we have to do this general processing, subsetting, do some value add if they have any specific regional concerns or format concerns, metadata and packaging forms as part of it. Then there will be regular meetings across, and we're not talking about a waterfall model wherein data is requested and it just takes at the end of it and then we present, but it's more iterative. We have meetings and discussions, and the idea is to make it more agile, based on agile methodology. And then if it is an interdivisional request, then of course there are interdivisional agreements to be in place. Now on the left side of it, if this data is not available, that is when the heavy lifting happens, right? So that's where the ETL process begins. We do data pre-processing, do transformation enrichment, interoperability and standardization, which is very important because there's a lot of talk between a particular format being used, but if it's not interoperable, then it's a challenge to stakeholders and also to people trying to put that data in their workflows. So that's an important step. Then formatting, packaging, and then any PaaS type of service, platform as a service, if you want to put it in a cloud environment, or if you have your own specific cloud instance that can be data can push to. So all that has to be taken into consideration, and then data made available as a query or an API, and as such. So there's a lot of IT side to it, but there's also the process side of things. The final delivery, of course, has to happen if it's an external stakeholder through a interagency agreement. That also takes a cycle, and then also we archive the data that is produced and into cloud for any future use. So accessibility is the key, right? A lot of stakeholders, both internal and external, they already know where the data set is, what format, where is it residing, directories as HTTPS requests and APIs, clouds, cloud instances, and S3 buckets that people can access and run them through scripts. The resources are there. You can read it, and it's all there on Earth Data Search, and anything that NASA produces on the dashboard has good information in terms of how do you access it, what are the scripts to use it, even points to repositories where you can use the scripts and pull the data. Then there are also the third-party collaborators who have the NASA data. They have curated to a point where they are making it available in a nice dashboard and map interface in a GIS type of data set that you click and drag and you identify the data and then pull it down. Or as a catalog where you search for certain queries and then you see a list of data set that are ready to be consumed. Before I get to that, but beyond this, there is the question of the last mile, right? So the data that the stakeholders need, is it being satisfied by what they get here? Or is there anything that is customizable and anything that is needed specifically that needs to be handed out to them? So that's the last mile problem that we at Applied Sciences try to understand and see if we can serve the community. So as we know, Earth observations through satellites are known fact, right? A lot of data has been collected, more so than ever. There is, again, a big push for data to be moved to cloud, and that is only going to alleviate a lot of data that is coming down from satellites. Now, one of the case studies that I would like to kind of push and also be involved more in applied sciences is on the agriculture side. And Vinita is actually putting together a working group where we are trying to understand how water, energy, food nexus is affected by climate and other related things. And agriculture as a food component is one of the bigger pieces where notice a lot of multiple climate stressors can affect it. And what happens downstream is food insecurity, supply chain related things. There are issues with productivity and a plethora of things. Okay, so that's why this is one of the key things that I personally am kind of interested in working on. And the data sets that NASA produces are up here listed. Seasonal temperature variations and forecasts, key ones, MERA2 from 1980 to present, GeoSF P5 and 10-day forecasts, and S2S 1-9-month forecast. Now, temperature is a big thing. Seen a steady rise in temperature. The past records, 19 years of the hottest temperatures per year have happened since 2000. So seems to be on right. So these data sets would help you, work on your products or work on your problems. The precipitation, NASA products, iMERC, their greenhouse gas emissions related, which of course these are the satellites that produce it, but then it's fed into models and processes, and then final emissions data is released. Drought and flooding, NASA products notice NRT, just on lands, if you are familiar with it. Then there's also NASA USDS map, soil moisture, and just had a conversation with a gentleman who's working in it, looking to make it cloud optimized, cloud ready, coming up September, October. So all of that is happening in the cloud and be readily available for stakeholders to access. And there's also crop CASMA as one of the products, which, if I must say, it's also being used as part of GMU's NASA project, and has a nice dashboard that I just showed you on GIS map, was used through that. There's some more additional data sets for those who are working food insecurity, food security related projects. We have some global data sets, some specific to regions. There's of course the crop CASMA. There's Fuse, which is very key for those who are in using it for people on ground in terms of participatory mapping, or NGOs who are looking for that data on specific regions. So all of that exists, and again, any of these data sets, data holdings that you would want to talk or discuss more, be happy to connect with you, and we can go from there. So continuing on the Act specific use case, in conversation with American Farmland Trust as one of the NGOs who has a good span of how they organize events and how they promote the use of smart agriculture and practices. And again, several crops, several decisions to be made by farmers, and at the end of it, they have to do it at their calendar, in their timeline. So this particular example we are saying is, we can go from regional or national level to regional level to a farmer's plot level or small size data set. Everything has to be either upsampled, downsampled, but then that flow should exist somewhere. So that last mile to the farmer, is it either from applied sciences or a third party who is looking into NASA data set and is curating enough so that the farmers could make a decision on time in terms of what crops to grow, what was my yield, what is the soil moisture, and how is that affecting my yield, and everything in between. So talking with some stakeholders, we've identified some of the key questions that they pose. And a good thing is that it is coming up ground up, which means they are asking, how can I be a part of the solution? From their point of view, it could be tied to carbon credits, to receive better value-added products. But then they also have concerns about the cost. Again, the profits in farming and agriculture usually upstream. So at the lower end of it isn't much. So what would they gain, and how much cost do they have to expend for that data usage? Processing the data at scale, I think cloud infrastructure is now matured enough so that processing is kind of coming down. But again, some of the questions and discussions you may have heard in other places includes, egress and how much, processing is happening. I mean, do I store the data and make it available, or do I allow functions and processing on top of the data, and at which point the egress cost would multiply quite a bit quickly. The data formats and standardization, we talked about that. And then rapid deployment is one of the key for this space. So latency issue, definitely. And iterative decision making, or at milestones, is what point do they make a decision? So this farm, for example, could be one of the 2 million farms that are here in the US and spanned across 10 or more agroclimatic conditions. So you can see the enormity of the data, and then if it can be scaled down and presented to different groups, then it can be could be very well received, I think. So some of the key decisions at which they or agriculture community tries to understand is crop season starts, say for example in winter, the inputs are identified. Then you have your decision halfway through the growth of plants to see if should I continue with the cycle, should I plant a cash crop, or should I, in between the two crop cycles, should I do a cover crop for various reasons? And towards the end, the economics also plays into the whole equation. Is, do I plant biofuels? Because I guess the way things are, 40% of all corn is now being used for biofuels, which means the economics is kind of driving the situation where biofuels could be used more and more. And then no-till versus till practice, one more traditional, other is more being pushed as the way to go forward. And then there are insurance benefits or issues if the crop fails, for example. And all along, I think at those two instances along this calendar, I think there should be a plugin of the data of Earth observing satellite data, including plant growth, and that also includes everything in between: soil moisture and the leaf area index. And DVI could help significantly and beyond. Also the yield quantification or classification of crop pattern by regions. I think that would be a big thing. So all in all, there could be some plugins for decision support system that somebody, third party or external party, could provide based on the data, on NASA data and resources. So I will kind of present this one before the last slide, wherein we are thinking how should we engage applied sciences with stakeholders, and what are some of the ways we can either co-produce or we can just present the data. So open science is a big thing, and at the same time, we want to engage with the stakeholders and co-produce the data so that it sees the end of life, sees value-added products, and that can be used directly in their workflow. So on the left side, you see the cataloging and the dashboard, NASA Earth data, and similar portals. And with 3 case studies that generally come through one is cloud-ready data set and stakeholders tech savvy in terms of pulling the data and using it in their workflows. The obvious way to get to it is, of course, S3 bucket. Data is dumped there, but then is it just data for public usage, or is it requester pays bucket kind of modality? That needs to be decided. Now, any processing that happens on top of this S3 resource, S3 object, is from the stakeholder side. Case study 2 is your standard gridded multidimensional time series data that usually and has been happening is searching and getting it from DAX. And the third part is where applied sciences, we're trying to see if we could have the specific focus in terms of having the collaborators talk with each other, or if there's a custom way of getting certain data sets and customizing it to your needs, we can try to apply some of the ideas and resources. And there's also the CMR, the metadata side of things, which kind of encompasses across all the DAX. This is for users to search the data products and work on it. So the reason I'm listing all of these is they kind of match with the the session speakers that we have here today. So me, Stephanie, and Helen from Applied Sciences side, which is what our case study 3 should kind of point to. Jess, Jennifer, and Vinita, they do with a lot of data processes through DAX, and then Dana is kind of does the metadata side of things and beyond. So with that, I will end, and there are certain, I believe there is a Slido at some point that also lists a couple of questions. So would love to hear from you, stakeholders of people who have experienced or used NASA data. So that would be really appreciated. So Thank you.
Thank you, Mukul. Next is Bob. Let's see the slide. There you go.
Hi, Justice. Welcome to Pittsburgh. Who has been here before? Okay, so a lot of you are first-time Pittsburgh visitors. If you need any advice, you know. So I'm at the University of Pittsburgh. Oh, I'm sorry. Yeah, I might have to. Is that? Let me know. Better.
A little bit better.
All right. Let's see. If I slide this forward, I don't want to drop.
Okay, that's good
Okay,
now.
I won't bump it. All right. Yes, I'm going to talk to you about the work that I do at the University of Pittsburgh. I'm at the University Center for Social and Urban Research, but I also manage a project called the Western Pennsylvania Regional Data Center there. I'm going to talk a little bit about that work. But really what we do is kind of serve as a civic data intermediary. So we come between data producers and data users. And in a lot of the work that we do is like very locally based, like working with community organizations, working with researchers kind of at our institution and other institutions here in Pittsburgh that have really locally focused work. So what we do is we assemble, transform, and maintain data. You mentioned the ETL process. We do a lot of that work in our work. I'm a team of, I have 5 people on our team. We disseminate information and apply data for impact. I'm going to share a couple of stories where we do that. And then we also use data to strengthen civic capacity and governance. And so that's like working with the data producers to make sure their practices are good and sound. And also like working with community organizations to make sure that they understand what they're working with, providing training and things like that. We're part of a community of practice organized through the Urban Institute, the National Neighborhood Indicators Partnership, and you're going to see that referenced here. But who can be a civic data intermediary? Just like first show hands, who has actually heard of this term before? So this is like a new term? Okay. And so communities can have actually lots of different civic data intermediaries. It sounds like you're an intermediary in what you do. But it's really kind of dependent on the ecosystem, like who is actually playing that role. And the local context in each of these communities really shapes the look of each ecosystem. There's not an organization like us in every community, and that's fine. Like we wouldn't fit in some places just based on the context. But intermediaries can be, lots of different organizations, people and programs at academic institutions, government departments, groups of civic technologists like Code for America brigades, state data center affiliates, consultants, nonprofit organizations, and library workers. And I have these documents up here. This is a project that we did with our academic library and our public library here in Pittsburgh, funded by the Institute of Museum and Library Services called Civic Switchboard, where we actually wrote guides for librarians and library workers to become kind of key players in their civic data ecosystems. This is the short executive summary version. This is the full report. I have some copies here if you want to grab one and take it with you. Don't make me take them back to the office. They're heavy. And also, if anything sparks you, like there's going to be an unconference session right after lunch, grab a Post-it, or I have a couple here, like something that you want to talk about. I'd love to be part of it. I'm going to be here the rest of today. And this is my first time kind of interacting with a conference like this too. So services that we provide in our project, just as context, we maintain through kind of a unique relationship, our city and our county's open data infrastructure. We publish the data. We handle all the publication around that, the ETL processes. As part of that work, we actually do a lot of data acquisition and transformation services. So this is one of our developers, actually actual photo, figuring out actually how to reverse engineer the data feed from all of our electronic parking meters a few years back. So he would go out onto the street, buy parking time, and actually watch that data show up. And he had to actually write all these scripts that actually give us real-time parking data now. We also do a lot of work with tools and dashboards. You've all seen interactive maps. I don't need to talk about that anymore. We also support a lot of community initiatives, and one of the things that we did a couple of years ago was just the Complete Count Committee and working on Census 2020 outreach and supporting the organizations that were working on that. We do project-based special assistance work, kind of involved with lots of community collaborations, and also like working with collaborations at our university. Like we've got an emerging collaboration around water data that I'm really excited about. We provide technical assistance, everything from office hours or emails that come in, just people asking questions about what data should I use, and then do a lot of training. And this is just like one photo from our data literacy materials, our data 101 training, where we like did everything hands-on because we realized like it's a terrible experience for people to all be in a computer lab at different levels of kind of like ability and experience, and so we just like took it all to paper and it had a pretty good experience. So that's like what data intermediaries do. They do all that stuff with data, so kind of connecting the data producers all the way through end users, and it doesn't always stop with like a dashboard or a data set on a data portal. And here's some of the work that we do, and others in our community do as Civic data intermediaries. This is the first tool that I'll talk about. This is the Greenprint tool. This is something that we built for the Allegheny Land Trust. They were really interested in which property should we acquire and preserve in some way as green in some way. So that could be, parks, that could be just leaving it go, it could be for urban gardens. So we had all this property data from our city and our county, pulled it together in an interactive map. You could click on a parcel, but then also overlaying that with a lot of environmental layers, like which areas are flood prone, where are the community gardens. We'd love to be able to throw more earth sciences data into this. We just don't always know what to do. The second one is just like stuff that we do all the time, like community profiles. I want to see what all of this data looks like in my community, everything from crime rates to property sales information to pollution and air quality, and like that's stuff that we don't know how to measure, and we know it's complicated. And I would love to be able to ask people, that aren't just at our university, like, can we actually create a census tract measure of air quality, from sensors that might or might not be in the community, and like what goes into the modeling? How should we communicate that if we can even do it? The third project is from our partners up the street at Carnegie Mellon, the Create Lab. They're great. They built a Smell Pittsburgh app with a lot of the local advocacy organizations around air quality. We've got some serious issues here, where it's like the ability to go on a cell phone and report how bad the air smells, because there's a lot of like contentious issues between environmental advocates and our county's health department around regulations of a couple of facilities. And so they wanted to just like create a way for people to actually create reports outside of the public process, so that they can be transparent and visible, and people can actually see like what's going on in different neighborhoods. And so you can go on here and kind of click on the map and see like what people are complaining about, like sulfur smells is a common one. And then that data actually is used with some of the modeling work that they've done with one of the organizations, where they have taken data from NOAA and like from these facilities that everybody's really concerned about, how does actually the wind blow? And can we actually look at that in a time series alongside all of these kind of complaints that are citizen generated, and just like use that as storytelling tools and ways to kind of advocate for better air quality. So those are just like things that data intermediaries do, right? They're connecting data producers and data users, maybe building tools in some cases. Other cases, it's just like answering a question, showing up in a meeting, kind of being there. And they're in a lot of places, and I'll talk about that. But a few challenges that people like me face in working with scientific data is like, data discovery. There's so much, especially in this space, like earth sciences, I wouldn't even know where to start. I wouldn't know who to ask. I don't have the scientific literacy. This is like me at a microscope sometimes. Like, what the hell am I looking at? But also it's like really important to understand the context, the biases, the limitations, especially with data like this. How is it collected? All those kind of things. Like connecting with domain experts. We have good local connections at our institution, not so good elsewhere. And so like knowing who to talk to when we have those questions about like, how do we actually create an indicator of air quality is one of those things. We also want to know, like, if you have really cool ideas for use cases, for the data that you're working with? I don't know, but I'd love to hear it. Working with complex data sets, like there's just like a lot of stuff that, a lot of capacity that you need to have. Just knowing what we should be thinking about is also helpful in terms of our own infrastructure. And then just explaining what it means to non-scientific audiences. Like if we go to a meeting with, organizations concerned about public health, like how do we talk about this data in an accurate way? And that's, I think, where a lot of you can come in. And so this is like what I look like in those kind of conversations. I feel like it sometimes. I'm not a scientist, but this is me doing science. Patrick Starr. But I think I want to close with this, just some thoughts that I had in preparing for this presentation. What can federal agencies do to encourage local uses of scientific data? It's like developing relationships with communities of practice is really important. This is where we kind of come together, all of us data intermediaries around the country that do the kind of stuff that we do through the National Neighborhood Indicators Partnership. I think there's a meeting in DC in October, our annual partner meeting. I think we'd like to have somebody there from that. I talked to Stephanie about that and made the introduction. So, if you want to talk to cities, there's a Chief Data Officers Network through Harvard, and also the What Works Cities Network. There's the State Chief Data Officers Network out of Georgetown, and they kind of have all these connections at a state level. So if you wanted to connect with state level agencies doing state level data things, that's a perfect place. And then lots of other ones, and these are just the ones that we've interacted with in our work. All-in data for community health, around public health. So develop those connections either individually or kind of institutionally. Build community partners into data governance processes. As you're thinking about new data sets or talking about it, pull somebody into that process of how would you use it? What would you need to get out of it? And this could be somebody at a local level, kind of an advocate, working in air quality in some community. Involve people in that process from the start. Make sure that you create guides, readmes, data sheets that capture details about data context, biases, and limitations. We've done that with a lot of property assessment data, but you don't want me writing one for the data that you touch, seriously. But it's really important to be able to say okay, here's how this is collected. Here is what devices are used. Here's the sensitivity of those devices and all those things, because that helps us not just with communities, but also if researchers want to reuse that data at our campus, or students want to use that data in a class project, that would be something that would make it so that they want to use that data, just having that documentation. And then also if you're involved with creating programs, thinking about dedicated federal support for civic data intermediaries and projects. It could be a big thing like a university center program like the EDA has, or the Census State Data Center program. It could be big. We'd love it if there was dedicated federal support for stuff we do. But even just putting that element of community engagement and community partnerships into proposal opportunities for us is great, because then that gets us talking to people, that gets people reaching out to us, and that builds those kind of connections that really help bring data to life. And so that's my contact information. Happy to talk more about any of this stuff. Seriously suggest a session for the unconference, and nice to be here. And grab a report, please. Thank you.
Thank you, Bob. Our next speaker is Joel from Impact Observatory. Right.
Is the camera okay? I'm not as tall as Bob. Okay.
You can look. Yeah, perfect. Yeah,
okay.
look perfect.
Great. So thanks. I'm with Impact Observatory. We are a company that uses artificial intelligence and machine learning to turn remote sensed information into actionable intelligence. So I'll talk a little bit today about the data that we create, and then I'll talk about how we get it to decision makers, specifically around some climate change applications. So we are in the midst of an environmental crisis, and we need decision makers to not have to worry about all of the topics that we're talking about here these 3 days and how we process data, make data, store data, use data. We just need to get them the answers to the questions that they can make decisions. So we focus on land use and land cover. So maps that tell you what is existing on the ground. Is it trees? Is it crops? Is it built area? What is it being used for? This is Mount Kilimanjaro from our model. And land use land cover is really at the core of all of the 3 Rio conventions. So the Climate Convention, the Biodiversity Convention, and the Convention to Combat Desertification. So there's obviously a lot of other factors that go into solving the SDGs around equity, around infrastructure, numerous topics. But really at the core of all of these is how are we managing our natural resources? How are we managing our forests and mangroves that store carbon? How are we managing our need to grow the amount of food produced while doing that in a climate-friendly way? How do we ensure habitat for biodiversity? So that's why we focus on land use and land cover. And until last year, global maps were at a fairly low resolution. There were global maps provided by several agencies at 100-meter or lower resolution. And they also were updated every couple of years. So you might be dealing with, if you're thinking about destruction of the Amazon rainforest, you might be looking at a map that shows standing forest that actually has been gone to slash and burn farming for a few years. Now, continental US, there's been great data that's updated much more frequently, provided by USGS. But globally, it hasn't been as good as we have here in the US. But now, thanks to advances in machine learning and cloud computing, you can create these global maps much more affordably and much quicker. And so what we've done is worked with Copernicus Sentinel data to develop a model that can create a global 10-meter resolution map on demand. So we did this by working with National Geographic Society to create a training data set of over 5 billion human-labeled pixels that we can then run over Sentinel imagery, which is available roughly every 8 days where you are on Earth. And after we had that model, we made sure that we were sampling globally to, again, to prevent this problem of biasing towards any one particular biome. Now, it is a global map. There are some limitations. There are parts of the world where we have better accuracy than others, but we feel that this was a pretty good sampling across all land cover types. And then we have a deep learning model that runs several tests over every Sentinel scene that's available to come up with a prediction of what it is. Obviously, there are changes seasonally. So what looks like a tree in the growing season for a part of the world might look bare in the winter if you're talking about deciduous trees. That's why we run the model several times over several images to create a composite. Then we take the most frequent prediction. So you're seeing here the actual RGB image, the prediction over a singular scene, and then the model takes every scene available to say, well, based on these dozens and dozens of scenes, this is what we think this land cover type is. Then we mosaic those maps, those individual scenes, back into one larger map, stitch them back together, and what we get is a global map. So we created and released, along with Esri and Microsoft Planetary Computer, annual maps for every year 2017 to 2021. Those are free, open source, CC BY licensed maps available both through Esri or Microsoft, or if you find me, I can give you links to access that data. And again, that is global maps at 10-meter resolution for those 5 years. So that's more data, right? And this session was supposed to be about data for decision making. So how do we get from, hey, here's this really cool new data source, to what are we using it for? How can folks actually leverage this, especially in a climate change context? So one way is we can take previously static data sets and make them dynamic. So these are 3 examples. Wildlife Conservation Society's Human Footprint Index, which looks at the growth of human footprint by taking in several factors: night lights, OpenStreetMap information, all sorts of data. and says, hey, where is the population growing globally? WCS had previously updated this index 3 times at a cadence of every like 4 to 5 years, which again, if you're thinking about sub-Saharan Africa, Southeast Asia, that's a pretty substantial difference in the human footprint in that time gap. So we've worked with WCS to take our annual maps, take that static data set, that great model that they've built, and put in dynamic land use land cover and those other data sets to make them dynamic. So now we'll be releasing, all 3 of these will be released soon. They've been delivered. I don't think they're public yet. I don't know the actual date they'll go live. But you now have the ability to look year over year. What's the change? A much more rapid cadence, helpful for understanding changes on the Earth. Same with carbon storage. So we worked with UNEP, World Conservation Monitoring Council, on their biomass carbon model. So there's a lot of above ground biomass carbon models. This is the only one that we've worked with so far. But again, something they get updated every few years. We've now given them that backwards archive to 2017, and we'll be updating that annually going forward. And biodiversity intactness, this is with the Natural History Museum out of the UK, looking at what is the difference in the expected habitat of an area and what the actual habitat is. So showing what's the ability for a species to exist in its kind of current footprint or range. So 3 cases where we've gone from, this is really interesting from a research point of view, I can look at this every 4 or 5 years, to I want to see annual change. And where we'd love to go is, can we get that to quarterly change? Can we get the same levels of accuracy on fewer observations, fewer scenes? So we're not there yet, they're still annual, but that's one way that we're trying to get data from kind of interesting to useful. The other example I was going to talk about is at a more local level. So the Florida Wildlife Corridor is a project that has numerous groups in the state of Florida working on it, from NGOs, local land trusts, county governments. The state government has actually endorsed this vision, including Governor DeSantis has signed off saying he wants to support using state dollars to go to this. And what the vision is, you see the darker green is what they call opportunity areas. So the vision is to make a connected corridor from the panhandle of Florida to the Keys, so that wildlife can migrate along its natural habitat. The Florida panther is their kind of flagship species they're worried about, but there's numerous other species there too. This is a really challenging vision to achieve for a lot of reasons. One, not climate related, 3,000 people move to Florida every week. So there's a lot of development that's going to happen that you can't really account for or predict where it's going to go. But climate related, there's kind of 2 big issues. One is, or 3 big issues. One is a managed retreat. As we see sea levels rise and more frequent storms, you're going to see people that want to still enjoy Florida, live on the beach, but the beach is going to be moving inland. So they're already seeing some of this inland migration. Miami has more blue sky flood days every year. So days where there's not a rain cloud in the sky, but yet you have flooding as far inland as 119th Street, 119 city blocks from the ocean, just flooding on a sunny day. The other climate related is changes in habitat. So if this corridor is where these animals can exist and migrate today, will that be the case in a climate change world? So how is natural land use and land cover changing? And then the third big one for this project is, if you think about agricultural land in Florida, you're probably thinking about citrus groves, which was for a long time the dominant agricultural product in Florida. But the citrus industry is on a pretty steep decline in Florida because less and less land is suitable for growing citrus. It's not that the land isn't suitable, it's that there's a fungus, green citrus fungus, that there's not a great intervention for that kills off the citrus crop. The way that this fungus used to be dealt with was it would kind of become an increasing problem, and then there'd be a Florida winter where there was a hard freeze, which by Florida standards is like 2 nights under 34 degrees or something like that. But the hard freeze would kill the fungus and kind of buy you another couple of years before it became a really big problem. Florida hasn't had that level of hard freeze since 1987. And so this fungus is now growing unchecked, which means that those citrus groves, which are actually pretty good for wildlife, they kind of function as standing forests to a degree, allowing some of that migration, are being converted to other uses. being converted to condos and shopping centers, and being converted to cattle farming, which is not as great for that wildlife migration. So that's the problem. So how do we help with our model? Well, we're working with Florida to provide those updated land use and land cover maps so that those groups that are working to buy and acquire and manage that land can understand where the pressures and drivers are. Where are you seeing change from forests to pastures? Where are you seeing change from open land to built area? A lot of times, while you think you might have a good grasp on where development is happening, if you go to every county board and planning commission and understand where land uses are changing, that's a really difficult thing to do when you're a loose coalition of kind of county and regional based NGOs throughout the state. So trying to just help them understand where land is changing. And how we're doing that is not just throwing them a big pool of data. This tool that you see, this is what we call O Navigator. This is our deployment of it, but if you Google UN Biodiversity Lab, there is a free public open version of this same tool that has over 150 global data sets available for anyone to go. And what we've done with this tool is tried to make it a straightforward way for a non-GIS expert to be able to just get the information they want about the data set for the area of interest that they want. So on UN Biodiversity Lab, there's an AOI that exists for every country and one jurisdiction down, so state or province, where you can go and for those 150 data sets, get just the top line number that you want for your AOI, displayed in a nice little widget that you can then download into a CSV if you want to analyze it in other software, or if you just want to see it visually represented. So we're trying to take some of this really complex, huge global data and say, well, what I really care about is Florida. Can you just show me what's going on there? Since I was asked to come here by NASA, I wanted to put some NASA data in. So I have the MODIS fire data set going back to 2001. So you can go and see where is fire impacting your AOI, which is again is important in this context of Florida, where they have, it's not like the West where they have fires, but as they think about trying to preserve some of those corridors, it's important. And here's the biomass carbon. So again, just a way to try to say, you don't have to go figure out where is the best biomass carbon model, to the point that Bob was making. I don't know where the data I want is. Then how is it stored in UNEP WCMC? How would I even get it? Do I have to email someone? Is there an FTP link? We're trying to say, here's the best peer-reviewed data sets available in one place, updated, the same cadence that they're updated. You don't have to worry if you're using the latest data, and it's something where I can just get that top line number I need. So where we'd like to go and where I'd love to invite some collaboration, one is we've begun talking with our folks at Goddard about how can we take that model from Sentinel onto the harmonized Landsat Sentinel data set, which would allow us then to have almost daily observations from free data sets. That's something else that we really believe in at Impact Observatory. There's tons of satellites out there with tons of really high resolution that's really expensive. And if you're a county board in Florida or a small NGO, you're just not going to be able to afford that data. So we really like to work on open data, really believe in the democratization of data. The other in the climate space we'd love to work on more is JEDI. There's a lot of interesting applications in understanding forest carbon, the health of a forest, the amount of carbon stored in a forest, that when you're working with LiDAR and can begin to get the better idea of the crown of a forest and the density of the forest, we can really unlock some insights about where we should be better protecting forests to store carbon, where we can see opportunities for regrowth and restoration for carbon storage. So that's another data set that we're keen to understand better, understand who's working with JEDI data already, and where we could collaborate. So there's info. I'll be around all day as well and would love to talk, and I can show anyone UN Biodiversity Lab and Navigator if you'd like. Okay.
Thank you, Joe. We are running a little bit behind time-wise. So next is my presentation. I'll keep it very short. And we also have posted the link to the Slido QCO chat. So if you have any questions, please post them in there as well, so we can take care of those questions after the presentations are done. So again, I'm Benita Kisi from Justice. I am going to talk about interdisciplinary community needs as it relates to water, energy, food nexus. And I have here, I think Jennifer sees online and Irina sees here. So I would like to acknowledge both of them here. So as we are facing bigger global challenges, the research community is actually moving away from traditional way of doing science, which is like discipline focused, to a more comprehensive and more interdisciplinary approach. And we have seen this growth in the community of interdisciplinary researchers or applied science groups. So as a data center, we need to understand you know, how we can help those interdisciplinary communities and think from more like an interdisciplinary perspective rather than from discipline focus like atmospheric science, hydrology. So, so that we can help those communities. And this session is about linking data to decision makers. It's not just the data sets, that we would like to use people from the interdisciplinary community use for their research. It's also that it also relates to the better decision making. So if you are thinking from multiple perspective, it helps you to make better decisions. That kind of reflects the interdisciplinary perspective as well. So as a water energy nexus, it is one of the interdisciplinary communities that's emerging lately, and we know that water energy nexus is very central to the United Nations Sustainable Development Goals, especially goal 1 and goal 2, end the poverty in all its form and everywhere, and the second one is zero hunger. And as Mukul mentioned, there are research that are impacting, like the climate change and all these things are impacting the food availability and all that. So because water, energy, and food are closely tied together, they really helped. This approach really helps to increase the resilience from climate risk. We are Justice. We are a multidisciplinary data holding, and I don't want to go into the details of Justice and how much data set we archive. I just want to focus here that we are a multidisciplinary data set holding, and we include observations and model data sets from atmospheric composition, also relating to hydrology data sets. Our data sets are also useful in the climate study of climate variability. So we really need to think from this multidisciplinary, interdisciplinary perspective. Who we are again Justice. We provide free access to data sets and it's open to public. We try our best to adhere our data and services to the fair data principles that you might have been hearing in other sessions as well. And we are a data center, but what we really do, we bridge the gap between data and science. We are the enablers of science, using, we provide some value-added services that will help the decision makers or researchers to better utilize our data set. And these are the data sets that are being curated at Justice. There are different missions from atmospheric composition, water cycle and precipitation, climate variability, solar missions. We do have model data sets that goes back to 1980s. And we have research derived data sets as well. Some are near real-time data sets like AIRS, MLS, and some of the new data sets missions that are coming are GeoCarp and JPSS2. And actually some of the missions that are in the asterisk are the end of the mission project. So This is the graphic that my colleague Irina provided. She's leading the publication management effort at Justice. And this is actually a histogram that shows the publication of 4,500 peer-reviewed articles that use these datasets. And you can see that our datasets have been used in variety of different disciplines. It's not surprising that our data sets are used in the environmental science and ecology. And if you look at the remote sensing discipline, and also meteorology, atmospheric science, geology, you can see that. But what I am also interested in looking at, like, what are the emerging disciplines that are using our data sets? Like, for example, geology. Our data sets have been used in this field. And you can see like some of the small number of researchers using our data sets in the plant science, and some in chemistry. So this is kind of very exciting that there are new disciplines that are emerging, and so we really need to think from the interdisciplinary perspective. So as a DAC, again, like, we need to think about developing some standards to help this interdisciplinary community. Basically, that means, like, we need to identify what kind of formats are they familiar to. Some prefer just using CSV format, rather than using some of our HDF and NetCDF formats. What are the tools they use? What is the preferred platform? What kind of analytics do they do? So these are the questions that we want to understand, that are coming from the interdisciplinary science community. And for that, we have recently proposed a new working group at ESDSWG. It's an interdisciplinary community needs working group. We have several phases of this working group. We are just starting and taking baby steps right now. We are at the phase 1 scoping stage, and though we are moving slowly, I think we'll be there. And the next phase will be exploration. We'll build some knowledge base, and then we'll build some documentations that will help our data centers, and most importantly, we need to disseminate those information. So that will be done in the phase 5. So that's all I have. If you have any questions about the working group, or if you'd like to get involved, let me and Jennifer know, and this is our email address. So with that said, thank you. I will take some questions at the end, but I would quickly like to move to another speaker, who is Dana Ostranja. She is representing SDISC. Dana, are you there?
I'm here.
Sure. Okay, so let me... All right, so Dana, you can go ahead.
Great, thank you. So thanks for joining today for the presentation of the Science Enabling Centers. This is an effort under the NASA Earth Science Data Systems. I'm Dana Ostringa, Assistant Project Manager at NASA ESDIS. Go ahead, next slide. So NASA kicked off a 3-year plan on the open source science strategy. And as part of that strategy, we want to make sure that we focus on each individual principle that makes up what it means for open source science, and then how we have that implementation and integration into our activities. So the principles for open source science include enabling science, better improved data governance, following standards recognized across the international community, improving the stewardship of the data, providing recognition to those who author the algorithms and scientists that develop data products, creating a sustainable infrastructure so that we can leverage services across disciplines, improving our education of how to access and use the data and services, and then collaborate. So that last one is really important, because having collaboration not only within our projects, but the scientific community, including our internal and external stakeholders and partners, will help us bridge gaps that currently exist. So next slide. So to expand on the support to transitioning to science enabling centers and implement the concepts of open source science, NASA headquarters had wanted to start focusing on 5 different areas. The first is the one that we already do really well, which is that data and metadata stewardship. The idea is wanting to make sure that the quality of data that's disseminated is interoperable and ready for use across the communities and various analysis tools. Then we have information management. So we just want to make sure that we capture and make accessible all the information related to the data. That includes algorithms, publications, platform or data source information, and make it searchable and easy to find for users. Then we have that open source software support. We want to make sure that we enable the management of open source software and make sure that the information on those different software packages is available for users. We have cross-mission science as a focus, kind of leveraging off of Vanina's recent discussion. We want to make sure that we're addressing any kind of interdisciplinary research and addressing any division needs within science to support those communities and facilitate data fusion. And last, we have that user support area. So we just want to make sure that we have subject matter experts available to answer any scientific questions about the data or information that we disseminate, and then make sure that we have all the folks that are available to support that open source software tools and services and address any kind of specific technical information. Next slide. One of the main questions I get asked when talking about science enabling centers is, how is this different than what NASA is already doing with the DACs? Well, not too much, but as of late, the tagline, bridging community initiatives, aligning goals, and fostering collaboration has been my favorite broad description. So what does that actually mean? We recognize that in the past, DACs have developed a really strong relationship with their user communities. They foster collaboration, creating requirements for new services and addressing those community needs. However, within the organization and our partnerships, there's also been initiatives to enhance the ability to access and analyze scientific data, foster more partnerships, developing non-standard mission products, or developing value-added products and services in various disciplines. So we want to create an environment where scientists and engineers can collaborate more effectively on these similar initiatives and share in technology and information to better serve the same or similar stakeholder communities. So by doing that, we'll make sure that we're reusing and not duplicating efforts and efficiently serving the broader user community. So to accomplish this, we really need to develop the foundation and framework of a science enabling center. And that's our first year's goal. Ideally, it's to establish what it is by forming a diverse team of individuals and define what an SEC is and how an SEC would formulate. Next slide. That team would also assess existing data centers, functions, and capabilities, as well as the disciplines that they're subject matter experts in. So we also want to capture a list of stakeholders, internal, who would contribute to the development of the science enabling centers, and external stakeholders who we know we'd want to reach out to during that development process to ensure that we're addressing the needs of that community, ensuring data democratization, and capture feedback for future development. In this initial period, we really want to make sure that we're able to identify technological areas that we can create a more enterprise approach to enable discovery and usability of the data. And then lastly, our initial goals, we really want to create a proof of concept of a science enabling center. So we're going to do that by focusing on climate modeling studies to help form the path for future SECs. Next slide. To provide a visual representation of the Science Enabling Center, we developed this preliminary value chain of the concepts and services as part of the development process. So not all SECs will encompass each of these components, but it provides a general guide to what it could be developed into in the long term. When considering new science enabling centers, we really want to focus on a discipline to make it as a step process as possible. We want to identify and model community needs, and we want to determine what kind of services would best suit the needs and facilitate data usage and research in that discipline. From there, it would eventually evolve to the point of access and dissemination. Next slide. So in our initial process planning sessions, we worked with other strategic initiatives and determined where there could be interdependencies with those new projects as well as projects that are already well established. We want to leverage existing technologies and information just to have an efficient initial development and rollout cycle of the science enabling centers. From there, we can really identify where we'd like to assess any new development opportunities. We want to make sure that we have adequate participation from those internal stakeholder members to ensure complete evolution of the Science Enabling Center. And so it'll really be critical to map out roles and responsibilities. Last, we want to emphasize the importance of communication and adoption to the external stakeholder community. So an outreach plan is really being developed right now by that development team. Next slide. As I mentioned, did it go? Okay. As I mentioned, the development team is currently working on building a foundation and framework for science enabling centers. So that means creating proper documentation for the implementation plan, a plan for outreach and communication, stakeholder identifications, and existing expertise and services that we can leverage. We want to make sure that the development process, the structure, and the dissemination is cohesive among all the SECs as they're developed and make it easier for our external communities to navigate. Next slide. So I've been asked on how someone can propose a new science enabling center. In this initial year, the development team has identified candidates for the first set of science enabling centers. However, this is evolving. So this was based on the efficiency of delivering an SEC, based on existing efforts in areas of high interest by the administration and community. But the development team is creating a process to propose new science enabling centers, and that will be reviewed by team and leadership. We expect that after the initial rollout of an SEC, it'll continue to evolve over time of what it actually is, especially in collaboration with the community as we capture needs that weren't initially identified during earlier development. And of course, I couldn't stress enough, the success of the Science Enabling Center can't be achieved without that participation, integration, and adoption from our internal and external stakeholders. Next slide. So who leads an SEC? I just want to mention that it's expected, who is expected to lead the development of a Science Enabling Center once the SEC is determined. The SEC could be led by one of the internal stakeholders with the coordination and initial development being supported by ESDIS and the DACs. The DACs have a lot of historical and current experience developing dissemination portals of data, information, and services, as well as outreach and communication to the external communities. So we really want to leverage those expertise and existing relationships. The ultimate goal would be that while there may be an internal stakeholder leading the effort, there's strong collaboration between all stakeholders and that all have a role in the development of the SEC. Next slide. So as I mentioned previously, we came up with an initial list of candidate SECs, with our first focus being on the Climate Studies Science Enabling Center. CSAC is what we've kind of called it with its acronym, will have a sub-area focuses on greenhouse gases, species distribution modeling, human impact data, disasters, sea level change, and sea ice, just to name a few. From there, this list will change and evolve as we work with headquarters on what our priorities are. Next slide. Initially, CSEC's development will be our initial minimal viable product of an SEC development process. So from a user's perspective, it'll somewhat emulate the Google Earth engine from that interface perspective.
Hi, Dina. I think we lost you.
So maybe this is Jennifer. I can just sort of continue what Dana just mentioned. So there is an MVP under Science Enabling Center. We call it Science Study Science Enabling Center, which is CSAC in short. But like Dana mentioned, we were originally used the Google Earth Engine approach. As we learn, a lot of research communities, they voiced out how great and convenient for the research community is using the Google Earth Engine. But what we are currently pitching is the framework based on what Dana mentioned is sort of making it better and within the purview of NASA Earth data system. So in a way, there are a lot of dependent components come in, and from headquarters under EOS this, under all the various stacks or processing centers to make it better. So next slide, Benita. Oh, all right. So that's the end of Dana's presentation. So I think Dana, we get you back. I just sort of covered the last slide from you.
Thank you. This is the problem with virtual attendance. So sorry about that.
No worries. I think we're good. So I just quickly cover the CSAC part, and that's it.
All right, thank you, Dana, and thanks, Jennifer. We have only a few minutes left, so I would like to open the floor to questions. And thanks to Dana.
Questions about that?
This is a hard question to answer, but do you actually know what decision makers, and I'm talking about, for example, county managers, actually, what data they actually use for decision making? So if you ask, it's kind of like asking the non-respondents, not the respondents.
So in the Florida example, yes, so we don't do that, right? But there's the coalition, actually called Florida Wildlife Coalition, is working actively with folks at the state and county level to say, here's our priorities, do you share them? One. Two, if you do, what do we need, what information do we need to provide to unlock funds from the state level to acquire land or to work better with local planning boards? They actually do a lot of work on those working lands I manage. So a lot of it actually is in the county is to go to a rancher and say, hey, do you care about the panther? And most of the time the answer is yes, these farmers are great people. So they say, okay, how can we help you be productive on your land and provide for some habitat connectivity? So in that case, I think that coalition does a pretty good job of saying, let's not come with the presumed answer. Let's start with how we make these mistakes. Other cases, it's all over the map, right? So we can create these great data sets and say, hey, folks working on the SDGs, here's all the answers, but they aren't always as practical as in the Florida case. You got to find who is the one working with. I could have another project about also that's a different topic if you want to follow up.
I wanted to ask, how are you all starting these collaborations with local governments, stakeholders, things like that, which I realize is a huge question, but I know there's been a lot of interest in ESIP over the last couple of years of trying to build community partnerships, and I've got a lot of scientific expertise and not a lot of expertise in figuring out how to get people to work with us. So I'm wondering if you're approaching people, are communities approaching you, how do you get these collaborations started?
It's just a lot of trust building, a lot of time, a lot of papers. Our project was like built on 10 years of just me answering questions in meetings about where are the vacant properties in Pittsburgh. That led to like, okay, we're going to throw stuff on GIS. And then it's like, go city and county, why don't you like trust us with your open data program instead of just hiring a vendor? But people know where to find us now because we've been out there. And so I would say like the advice I would have to do is leverage those relationships that already exist. Building it from scratch will take too much time. So find the people that have those relationships, work with them, and then you can kind of leverage that to
I would second all of that. And actually, I was talking to Nicole last night. I'm not the technical expert in my organization. My background is policy and partnership building. So, as a data company, IO set out and said, well, how do we get to the right people? And it wasn't to go a traditional business development route, it was to hire somebody coming from that community world. And again, second, don't build it, find the people and network through existing organizations who have long community funds.
Yeah, I'll second that before I just get to the questions. Karen and I are co-chairs of the Disaster Lifecycle Cluster. We've participated in it with a group called the All Hazards Consortium, and it's the food, fuel, communications, transportation, medical supply, logistics, communities, DHS, and FEMA. We've participated in those weekly Friday calls every Friday for 7 years. And it wasn't until the first year and a half passed that everybody on that call started to trust us, because they see so many people fly in and try to do something and then get a sale or do something else and then leave. So it really does take that persistence. And I was just going to say, this question is for Bob. I think Karen mentioned it to me. She said, I think I found myself here at ESA when she heard the term Civic Data Intermediary. And that's one of the things that we're trying to do with the disaster lifecycle cluster, and that is to connect with communities and deliver science data to non-scientists. And to do that takes a lot of relationship. So we're on that path and that journey here in ESA. We're doing it, and we're leveraging different data types. So I was really just going to make the point, Bob, to you that we want to find out more, work with you to see how we can work with not only coalitions and collaboratives in Colorado on the wildfire problem and getting into communities. They have a big data gap. We want to bring that solution to them, but it has to be through building relationships. So I think, the Civic Data Intermediary may become a new term within the disaster lifecycle cluster. So thanks for that.
Hi, I'm Elizabeth Joyner of NASA for Science Data Systems. I echo what you say about tapping into other groups that you work with that have relationships, but I also want us to be cautious about that, because the federal government has a long history going into these historically under-engaged communities and saying, we want to do something in your community. And want to be conscientious about that as we tap into the long-standing relationships that our colleagues have, and making sure that making sure that we are reciprocating within those communities. And I think that the term reciprocate is really
you. I'm Karen Lowe. Retired from NASA several years ago. Have been kind of stumbling into this role over the last 7 years of being that kind of representative community where I live. And when the question came up about the county, I started out at the town level, where I've lived for like 30 years. So I know the people there, but it's only been in the last 2 years of really understanding at the whole level of government, and when you're trying to get things done on a policy level and protect your community right now, major focus is air pollution. How do you go about that? I really feel like I've just kind of fallen into it. Just last week, I met the director of our Department of Environment at the county level. So she's actually very interested in what we're doing. So it's like, that just kind of happened. How I stumbled into it. But I do want to take advantage of it this morning. And just that idea of coming up with what Dana was talking about, those centers. And so I'm very interested in how we might participate in something.
I'd just like to make one other comment or observation, being an original ESA member, and that is that I made the comment to Karen while listening to the presentations, that connecting with communities and finding users for NASA data. I've heard that for 20 years, right? I mean, it's what we hear all the time. We want to connect with people with data, and we want to collaborate more and all that sort of stuff. And so I'm hoping that what we're talking about here at ESIP really really is going to turn into action. That we can connect like what we're trying to do, and we're not just listening to presentations and then going home. That we're really making relationships and we're putting together these connections, because this is where it's going to happen within ESIP. The biggest thing that concerns me is that a NASA project comes along and you write a proposal and you get 2 years of funding or 3 years of funding. You make these relationships with people and then boom, project's gone. More funding needed for another project, for another priority and all that stuff. And communities are left hanging. And while they might see a need and a value for NASA data or other federal agency data, if they don't have that ongoing support or they can't make themselves sustainable, it just goes away. And then guess what? Those people retire, people from NASA move on, new people come in and say, we want to connect with communities. And so we just see it go round and round. So I hope that we come up with some really tangible things.
There is one.
So I'm really happy to see someone representing a data center here. Just a quick word of advice: if you want to connect with communities, look out for data centers that use census data, because census data has been used by local communities for a very long time, but there's a lot of knowledge. Also look at the community informatics literature, so there are a lot of do's and don'ts out of that literature. And connect with your university's urban planning department, because they worked a lot in trying and sometimes succeeding in disseminating raw data or some featured engineered data to local communities. Questions?
So I love the impact observatory mapping. I think that's really cool. The question that came up for me is, are you able to, for an area of interest, for example, give a user some indicators of rate of magnitude of change over time? So if you're doing the maps, and I would ask the question, okay, well, I'm concerned about my capital. Could I pop out some indicators of rate of change and magnitude of change, get a sense of where are we really seeing the rapid change taking place?
So currently we have those time series for 2017 to 2021, and so you can do some of the simplistic plus minus change over those years. But where we are actively working on getting to showing a better representation of change and being able to do it on demand. So you can say, here's a threshold. If my county loses 4% of forests, I want to know. So change detection is very much on our R&D roadmap, and going from a simple pixel plus minus, where you have compounding levels of accuracy year over year, but still gives you an idea to how can we get really thorough change detection, because that is what decision makers want to know. So we're heading there.
So we are out of time, but we do have some questions in the poll. I don't know if you were able to see that. So we wanted to capture any decision-making tools that you have used now or in the past. So if you have that, please indicate that in the poll. So I will paste the link to the online participants here. So I think that would be also one of the things that we're really looking forward to. What are the decision-making tools that you are using, and if there are any pain points related to the data sets, what are those? Even after the session, maybe you could just indicate that. I think that would be great. So we can. Oh yes, sure. Thank you. We just have one response, customized dashboard. So we'd love to see like what other tools have you used in the past. And with that, I would like to thank all the speakers and the participants for